Well, today I'm going to introduce a couple of techniques for integration. First is integration by substitution. Okay, let me start with example. Example 1. Three x squared x cubed plus 1 to the 10 dx. Look at this problem. We cannot find the integration using the techniques we used in last section. The reason is the integrand is product of two terms, right? Product of two functions. And unfortunately, we don't have product rule for integration. But this integral is doable using the substitution method. Let me show how. Let x cubed plus 1 be the new variable u, then du over dx is 3x squared, right? You see my point? Let me multiply both sides by dx. Then I get du equals 3x squared dx. Right? Okay, good. Then let me write original expression, that is 3x squared x cubed plus 1 to the 10 dx. That will be in terms of, let's write in terms of u. Okay, this expression is u, so u to the 10, this is u to the 10, and let's see, 3x squared dx, 3x squared dx, 3x squared dx is nothing but du, so it will be du, which is readily integrable, right?
Mm-hmm.
Okay, what is the integral?
U to the power 11.
U to the 11 over 11 plus constant of integration. Thank you. Okay, let's plug back the value of u. What is u? X cubed plus 1. So x cubed plus 1 to the 11 over 11 plus constant of integration. This is the integral, this integral. Right? Okay. Let's do the second example. Example 2. X times e to the x squared dx. What do you want to substitute for?
X squared.
Okay. Let new variable say z equals x squared. What is dz?
2x dx.
2x dx. Perfect. Okay. Then let me say this is I, integral I. Then I equals, let's see, integral sign, this quantity is e to the z, right? E to the z. What is the value of the rest? We have some more stuff here, see? This is e to the z, we have x dx here. We know 2x dx is dz. So x dx is dz over 2, right?
Yes.
X dx equals dz over 2. So we can write x dx in terms of g as dz over 2. You see my point? Okay, let me pull the constant out. We are left with e to the z dz. Okay, this is readily integrable, right? Okay, see, this is half. Integral of this is e to the z plus constant of integration. This is half. What is z? Z is x squared. So e to the x squared plus constant of integration. This is the integral. Do you see my point? Do you have any question?
No.
Okay, good. Let's work on another example. Let me take this example. Example 3. What is the integral of 5x square root of x squared plus 3, x squared plus 3 dx? What do you want to substitute for in this problem?
X squared plus 3.
Perfect, yeah, absolutely. Let t equals x squared plus 3. What is dt?
2x dx.
2x dx. Okay. Let me write this, say I, so that I don't have to repeat the long expression. Then I equals, let's see, x squared plus 3 is t, square root of t, right? 5x dx. Okay, we have 2x dx equals dt. Okay, 5 is not a big issue because we can pull it out. Okay, let me write 5 as it is. 5 as it is. 5 came from here to here. I need the value of x dx. X dx. Let's go back to this expression. 2x dx is dt, so x dx is, what do you think? dt over 2, right? Good, good. This is dt over 2. Okay, 5 is in the numerator, 2 in the denominator. Let me pull out of the integral sign. 5 over 2, integral. Square root of t is same as t to the half dt. Okay. This is 5 over 2. Integral of t to the half. T to the half plus 1. 3 over 2 divided by 3 over 2 plus constant of integration. Do you see my point?
Yes.
Okay, good. This flips, so 2 over 3, 5 over 2 times 2 over 3, t to the 3 over 2 plus constant of integration. This is 5 over 3. Let me substitute for t. What is t? X squared plus 3. So x squared plus 3 to the half 3 over 2, sorry, to the 3 over 2 plus c. This is the required integral. Do you have any question?
No, sir.
Okay. Okay, let's go to the fourth example. Example 4. Natural log of 5x squared over x dx. What do you want to substitute for?
ln 5x squared.
Okay, let absolutely. Let u equals natural log of 5x squared. What is du?
1 by x is 5x squared.
What else?
And 10x
Times
over
10x. Okay.
10x
Okay.
by
Let me explain. Okay. If u equals ln of fx, then du over dx is 1 over fx times f prime x. So, look, u equals ln of fx, fx is 5x squared, so 1 over 5x squared. What is f prime x? Derivative of 5x squared. 5 times 2x, right? So 10x over 5x squared, that is 2 over x. Okay. Du over dx is 2 over x. So du is 2 over x dx. Do you see my point?
Mm-hmm.
Okay. But look here. We have integral sign. Ln of 5x squared is u. We are left with 1 over x dx. We have 2 over x dx. So we need to know what is 1 over x dx, right? 1 over x dx is divide both sides by 2. You get du over 2. Do you see my point?
Mm-hmm.
Yes? Okay. Then, let's see. This is our u. 1 over x dx is du over 2. So, du over 2. We can pull that constant out. 1 over 2 integral of u du. That is 1 over 2. What is the integral of u du? U is squared over 2 plus constant of integration. U is squared over 2 plus constant of integration. That is u squared over 4 plus constant of integration. That is, what is u? Ln of 5x squared. Ln of 5x squared, right? Are you following me?
Yes.
Whole square over 4 plus constant of integration. This is the integral. Do you have any question?
No.
I think 4 problems give you pretty clear idea about how to use substitution method for integration. Okay, next let me introduce the method known as integration by parts. Next is integration by parts. For this we need to remember a rule. Let me write rule. Rule says integral of u times dv equals u times v minus v times du. This is the rule. Okay, let me provide you the proof of the rule first. You remember the product rule for differentiation, right? By product rule, for derivatives, d over dx of u times v equals u dv over dx plus v du over dx, right? This is the product rule of finding derivative. Okay. Let's multiply both sides by dx. What happens? D times u times d of u times v is u dv plus v du. Did it make sense? Multiply both sides by dx. Okay. Then let me give you the region. Maybe we need to mention here. Multiplying both sides by dx. You get that? Okay, this dx goes away, dx goes away, dx goes away. So we get this expression. Does it make sense?
Yes.
Okay. Next, let's integrate. On integrating, what do we get? We get integral of d u plus v equals integral of u dv plus integral of v du, right? Right? Okay. Let's see. U and v are functions of x. So is u times v, right? U times v is another third function, so is w. So integral of dw is w, right? So integral of this is u times v. That equals integral of u dv plus integral of v du. Okay, let's solve for this quantity. What happens? If we keep this as it is, let me move this to the left. It becomes u times v minus v du equals u dv, okay? Let me write solving for integral of u dv. We get integral of u dv equals u times v minus v du. That's the rule of integration. So proof is kind of straightforward. We can get from product rule of differentiation. Now we're gonna use this rule to integrate some of the functions. Oh, let me keep the rule. Let me erase the proof, okay?
Okay.
Let me start with example 1. Example 1. Integrate x times e to the x dx. Note that this is, see, product of x and ex, we cannot integrate directly, we cannot integrate by substitution. So we need integration by parts. Okay, to use integration by parts, first thing we need to do is, what is u and what is dv, right? Okay, in this expression, let u be x and dv be e to the x dx. We are going to use this rule. So once we have u and dv, we need to know u, v and du, right? So let me find du, that is dx, and b is, okay, you are given dv. To get v, you have to integrate both sides, right? So if you integrate this, you will get e to the x. Yeah, please note that we don't write plus c here. We write plus c after integrating this at the end. Okay, then what happens? We have, let me show you here. This is our u, this is our dv. So integral of u dv, integral of u dv. So using integration by parts, this equals integral of x times e to the x dx equals, okay, this is u dv equals u times v. What is u? This is u times v, that is x times e to the x, right? X times e to the x minus v du. This is the v, what is du? This, right? So e to the x dx, e to the x dx. So x e to the x minus integral of e to the x is e to the x plus constant of integration. If you want, you can go one more step. E to the x, x minus 1 plus c. This is the integral. Do you have any question? Okay. Okay, let's do next example. Example 2. Integral of x, natural log of x dx. What do you think? Which one is u? Which one is v? Let
u be x.
u be x and dv be the rest, right? ln x dx. Let's see whether it works or not. If it doesn't, then we'll have to fix. Okay, let me, before starting this problem, let me go back to this and remind you something. We assume some function as u, the rest of the stuff is dv. We calculated du and v. Okay, we assumed u and calculated du. We assumed dv and calculated v. So it's very clear that u must be easily differentiable, because once you have u, you should be able to find du right away. Here, once you have dv, you should be able to find v right away. So let's note that. Let's note that here. Note. U must be easily differentiable and v must be easily integrable. dv, right? dv must be easily integrable. Because once you have u, we should get du right away. Once you have dv, we should be able to get v right away. Okay, let's go to this. Okay, if u equals ax, we can find du, that is dx. But once we have dv, what is v? Integral of this, right? ln of x, natural log of x dx. Oh, maybe we got to a problem. Maybe we are stuck here. Do you know what is integral of natural log of x? No?
No.
No, that's not easy anyway. Not easy. This means b is not easily integrable. Okay, then I guess at this point our assumption is doesn't work. So does not work. We have to be careful while taking u and dv. The reason is, let's see, u doesn't hurt because once you have u equals ax, you can find du equals dx. But once you have dv, you couldn't find v, right? We couldn't find v. Okay. Then we need to change our assumptions. Okay, because dv must be easily integrable. Let's do that. Let's do that. Can I erase this part?
Yes.
Okay. I'm pretty sure we can fix the issue. Okay, there is no reason we need to assume u equals x. We might assume u equals natural log of x, right? Okay, let's see what happens. Let u equals natural log of x and dv equals x dx. Then du, we can find derivative right away. Derivative of natural log of x is 1 over x, and dx switches this direction, 1 over x dx. du is 1 over x dx. When dv is x dx, b is integral of this, right?
Mm-hmm.
That is x squared over 2. Okay, both we can find them. And let's use this rule, okay? Because this is our u, and the rest is our v, dv, this quantity is dv, integral of u dv equals, using integration by parts, do you see what I'm doing? Do you see my point? So this is I. Using integration by parts, I means integral of u dv equals u times v. What is u? ln x. What is v? X squared over 2 minus v du. What is v? X squared over 2, du is 1 over x dx. X squared over 2, 1 over x dx. Do you see my point? V du. Okay. That equals x squared over 2 ln x. Let me write x squared ln x over 2 minus, this is constant and we can pull out, right? Then we are left with x squared over x, that is x dx. So if I pull out 2, then I'm left with x dx in the integral sign. That is x squared natural log of x over 2 minus half integral of x dx is x squared over 2 plus constant of integration. That is x squared ln x, natural log of x over 2 minus x squared over 4 plus constant of integration. Do you have any question?
No.
Oh yeah, see, this problem helps out to see very clearly. We need u to be very easily differentiable and dv easily integrable. Yeah, please note this. Let's try one final problem. I think after this you'll see how to use integration by parts very clearly. Okay. Let's try example 3. Suppose you are asked to find the integral of natural log of x with respect to x. We cannot find integration directly because we don't know the integral of natural log of x. Substitution doesn't help. We need to use integration by parts, right?
Yes.
Okay, then even for integration by parts, you need to identify which part is u and which part is dv, right?
Mm-hmm.
Okay. What is your u and what is dv?
U is easy differentiable means ln of x.
Okay. Wait. If u is natural log of x, then it is easily differentiable. Yes, perfect. What is your dv then?
dv is dx.
Perfect, yes. U equals natural log of x and dv equals dx. If we assume that, then you can find du, that is 1 over x dx, right?
Mm-hmm.
Do you see my point? What is v then? Straightforward, right? V is x. Okay. Let's see what we have done here. This is EU, this is dV, right? Integral of u times dV. So using integration by parts, integral of natural log of x dx is u times v, right? We are going to use this u times v x times natural log of x minus integral of v du. What is v? X du. X times 1 over x dx. That is x natural log of x minus x and x cancels, integral of dx, right? Do you see my point?
Yes.
Okay. This is x natural log of x minus x plus constant of integration. Do you have any question?
Is C or K same?
Oh yes. Generally we need to write what K represents for, where K is constant of integration. Thank you. Yeah, we did 3 different examples using the integration by parts. So hopefully you have kind of good idea how to use integration by parts. I have some more problems collected in my note. Yeah, you can see those problems in Blackboard. Please try those problems. If you have any questions, let me know. We'll work on next class. Thank you. Thank you for your patience.